Given question, find the stress developed in aluminum cylinder and copper cylinder.
When two different materials are fastened together, then it is known as compound ties or struts. In this case, there are two conditions. Total load is shared by two materials. So suppose if we consider material A and B, then we can say that P is equal to PA plus PB, and the strain produced in both the material is also equal. So we can say that rho A is equal to rho B. Now if we observe this given question, then there are two materials, aluminum cylinder and copper cylinder. Length of copper cylinder is 500 mm and length of aluminum cylinder is more than copper cylinder, and it is 500 mm plus 0.15 mm, that is equal to 515 mm. So when we can apply these two rules for the compound ties or struts, when this aluminum cylinder is compressed up to a length of this copper cylinder. So we have to first find out load required to compress this aluminum cylinder, and for this delta L is equal to 0.15 mm. And then when we subtract this load from this total compressive load 500 kilonewton, then that remaining load is shared by these two materials, aluminum and copper. So there is one condition for the compound ties or struts, that the length of these two materials should be equal, and here this is the question for unequal length. So we will first calculate the load required to compress this aluminum cylinder. For delta L is equal to 0.15 mm. So with reference to this diagram, we will take E, that is Young's modulus for aluminum, is equal to stress by strain. So stress, that is P divided by A, and strain is delta L by L. So this is the simplified formula. So P is equal to EA delta L by L. Now for aluminum cylinder, we will take E for aluminum 70 giganewton per meter square. So giganewton, we have to convert it into standard unit, 70 into 10 raised to 9 Newton per meter square. Then area. So if we observe how to calculate area of aluminum cylinder, so its inside diameter is given 60 mm and outside diameter is given 70 mm. So area of this material is equal to pi by 4 inside the bracket 0.07 square minus 0.06 square multiplied by delta L. So delta L, that is this elongation is given. So we have to take standard unit as a meter. So 0.00015 divided by original length. So what is the original length of aluminum cylinder? That is this 500 plus 0.15. So here we have to take 0.515. Now we will calculate this. So when we calculate, we will get the answer 21,434.9 Newton. So this is the load required to compress aluminum cylinder up to a length of 500 mm. So total load given is equal to 500 kilonewton. So from this 500 kilonewton, we have to subtract this load in Newton. So 500 kilonewton, we have to convert it into standard unit, that is Newton. That is 500 into 10 raised to 3 minus this load, which is equal to 478,565.1 Newton. Now this is the remaining load which is shared by both the materials, that is P aluminum plus P copper is equal to this load. So this is the one equation we get from the calculation. So we will give here as a equation number 1. Now we will take the second rule. We know that strain in aluminum is equal to strain in copper. So how we can write this in terms of sigma? So we know that Young's modulus E is equal to sigma by strain, and therefore strain is equal to sigma by E. So we will write the equation equation sigma aluminium divided by E aluminium is equal to sigma copper divided by E copper. We will get this second equation because we know the value of aluminium and copper for Young's modulus E. So sigma aluminium is equal to 70 divided by 200 sigma copper, and which is equal to 0.35 sigma copper. So this is the relation in between aluminium material and copper material for the stress sigma. So I will underline this equation number 2. Now from equation number 1 we can also take the equation in terms of sigma, because here it is given that P aluminium plus P copper is equal to this value. So we can write here, instead of P aluminium, sigma aluminium multiplied by area of aluminium cylinder plus sigma copper multiplied by area of copper cylinder. Now we will put the value of area for aluminium and copper cylinder. It is equal to pi by 4 d square. So when we put this value and we will replace this sigma aluminium which is equal to 0.35 sigma copper. Now if we observe this equation, then this equation is in terms of sigma copper, that is there is only one unknown term sigma copper, and when we calculate this we will get the value sigma copper is equal to 12,707.5 into 10 raised to 3 Newton per meter square. So we will write this in mega Newton per meter square. It is equal to 12.7 mega Newton per meter square. So this is the value of sigma copper, that is the stress in copper cylinder. So what is the value of stress in aluminium cylinder? So here is the relation in equation 2. So stress in aluminium cylinder is equal to 4.44 mega Newton per meter square, but it is related to load equal to this load shared by these two cylinders, and to compress this 0.15 millimeter there is one load, and we have to also calculate sigma aluminium for that load. We have calculated earlier the load required to compress this aluminium cylinder equal to 0.15 millimeter. So this load is equal to 21434.9 Newton. Now we have to calculate the stress developed due to this load in aluminium cylinder. So how to calculate this? So we have formula sigma for aluminium is equal to P divided by area of aluminium cylinder. So when we put the value we will get the answer 20.9 mega Newton per meter square. So this is the stress developed due to this load. And earlier we have calculated sigma aluminium is equal to 4.44 mega Newton per meter square. So total stress developed in aluminium cylinder is equal to 20.9 plus 4.44, that is 25.34 mega Newton per meter square. So this is the answer. We have to calculate total stress developed in aluminium cylinder, and stress developed in copper cylinder is equal to 12.7 mega Newton per meter square.